I guess we are ready to start. Welcome. Thank you for attending. This is going to be a talk on Backbone.js and some associated tools that help improve your front-end workflow. My name's Tim Branyen. I go by @tbranyen online. That's just my online alias for GitHub and Twitter. It may be useful if you wish to look up some of the code afterwards. The slides will be made available. I'll give you a link at the end of the talk so that you can view them online. Right now, I'm currently working on improving learning online open web technologies at Bocoup in Boston, where I'm an open source web developer. I've been contributing to Backbone and promoting it for over 2 years. And through that, I've created 2 popular projects, Backbone Boilerplate and Backbone LayoutManager, which aim to improve how developers work with that tool. And recently, I co-authored a book called Backbone in Action, which you can look for on any major book site. I have 1 hour to teach you pretty much everything I know about building web applications, which is no easy task. I typically train companies for over a course of a couple of days doing this. So I'll be rushing through some of the concepts. Hopefully what you get out of this is a better idea of how modern web development is taking place and what tools you can use to help better your own process. I'm going to show some simple ways of developing because I find that often simple ways are the best way of developing. If something becomes too complex, maybe you're doing something that's a little bit incorrect. I have a very bad history of live coding, so I will not be attempting live coding during this, but I will be showing concepts of the code and diving into an actual application that's not too complex to understand. This will not be much of a debate between the server side and the client side. I believe they're not mutually exclusive, but you can actually develop them mutually exclusive, which is interesting. They're both necessary depending on what you're creating. So that's a good way to decide about how you're going to architect your web application, because a web application doesn't necessarily have to be just JavaScript or just Java on the server. It can, you can mix and match these things. So are you creating something that's about the content? Is the content really why somebody's coming to your application, or is it about the functionality? And I feel like that's a really good distinction to make in your head when it comes to architecting these type of things. Are your end users on very low bandwidth? Are they going to be remote? Are they tele-inning on their cell phone from who knows where? I mean, you need to think about, do you even know what device they're on? That's another good question. If you don't even know who's going to be using this, there's a good chance maybe they're not even on JavaScript. They're using a screen reader. And another big thing to think about is if SEO is vital to the success of your application. There are a lot of services out there now that attempt to make a client-side web application SEO friendly, but what it really comes down to is whether or not you have quick response times. Like Google will measure how long it takes for your site to render and respond. So it's nice to be able to have some of those things cached at a server level. What I have here is a Venn diagram about websites and versus web apps. I've been using this graphic now for a few years in my talks because I think it's the simplest way to express how most developers see the difference, the dichotomy between a website and a web application. In my mind, a website is content that's rendered by the server, and it's meant for accessibility. It's meant to have the widest reach possible because that's what the web is about. It's about reaching as many people as possible. And then on the other side, you have a web application, which it's a weird term to use because you can have a web application that's written entirely on the server and delivered. But when I say web application, I mean something that's very rich, that has very low latency transitions and routing. It's really geared towards performance so that when you use it, it feels like you have a native experience or as close to that as possible. And in the middle ground, we have what's called progressive enhancement. And this is a term that's been floating around now for a long time, and I feel like many developers kind of conflate and confuse what this actually means. Progressive enhancement isn't about whether or not your application works with JavaScript on and off. It really means layering your application and understanding who's going to be using it at what stage. Is someone going to be using it without JavaScript? How does it react? Are they going to be using it without geolocation? How is it going to react? It's being able to layer those. This talk will be primarily in pretty much entirely on the client-side aspect of web application development. I know this is a conference full of Java developers, and you guys are probably crazy with your server-side foo, But in my opinion, when it comes to building a modern web application, the best tools that exist have been developed by the client-side developers for the client-side developers. So it's interesting to look at what it has to offer. The server is entirely optional when you decide to go client-side only, which it can be really cool for deploying to something like PhoneGap or Chrome apps. That's not to say everyone does this, but it gives you that sort of flexibility where you're not tied to this certain server that has to exist at all times. It gives you offline access. There's a lot of benefits there. There's some APIs that are only available on the client side. So if you're interested in doing real-time communication, the WebRTC APIs are pretty prolific now between Chrome and Firefox. You can build some really dynamic and engaging experiences. There's also WebGL, which is very similar in that regard, where you can build these rich experiences that can only be coded on the client side. And as I mentioned before, the last thing that I find most important about client-side applications is the performance. You get very low latency routing. That means when you make transitions, you don't have to do a round trip to the server. In any regard, you can actually build out all your templates and layouts in the browser, download it at once, and then quickly switch through these. Okay, so this is my favorite web application, and this is how it looks without JavaScript. It doesn't look too great. This is how it looks with JavaScript enabled. So this is very much a client-side web application. It gives you native fields. You can transition easily between things without reloading the page. Let me switch back here. It doesn't do well, like I said, without JavaScript, but that's fine because that's not what the target audience is. The target audience will be running JavaScript. This is a Chrome app that you're installing through Chrome. On the flip side, we have Twitter.com, and this is how Twitter looks without JavaScript enabled. And if we take a look at how it looks with JavaScript enabled, it doesn't look that much different. Really, what you're noticing on the left are some of the progressive enhancement, where it puts in some fetching from related tweets and being able to post a new tweet. I almost never use this website, but when I'm remote and I'm on a very low connection, I typically will go with this, just because you get content very quickly while it's still loading in JavaScript. And Twitter just recently switched to this setup. I had to replace the screenshot in here because old Twitter used to rely much more on JavaScript, but they've been moving away from that back towards the server. And their reasoning for that was that they were having initial load performance. It was taking too long for users to see content. But I don't actually buy that. I think that with some intelligent design decisions, you can get very close performance to this with pure JavaScript. And there's some techniques for that. Like you can bootstrap data. You can send data down with the markup request for, like, let's say you're fetching index.html. You can have your server embed data that's necessary to render with JavaScript in that request, so you don't have to make yet another request to get data. You can lazy load JavaScript and make sure that stuff that's not necessary for that initial page isn't loaded until later. So you can actually show content now and then asynchronously fetch more data. And then lastly, using caching. Like, use caching to your benefit. It's there for a reason. Minification allows you to remove a lot of white space, dead code, and lastly, static Gzip. This is something that a lot of developers don't think about, but just Gzip your content in your deployment process and have your server configured to just statically serve that instead of wasting CPU cycles generating Gzip on the fly. So this is a talk that's heavy on JavaScript. It's the open web programming language. It is ubiquitous within every web browser that supports the open web stack. But at the moment, it's not really ideal for building large web applications. We've had tools for a long time to supplement and fix this, but there are some inherent problems with the language that are being addressed in the next major version called ECMAScript 6. That's being put together by the TC39 committee, and it's right around the corner. They're slowly finishing up all the pieces, and Dave Herman, who's chairing the modules, so JavaScript does not have modules and it will be getting it, he's been championing that spec, and he's been tweeting recently that it's almost complete, so that's fantastic. You can start using some of it already through the use of transpilers, so there's nothing stopping you from writing code in ES6 today. So we're going to look at what Backbone gives you and what it doesn't give you, and really what is Backbone. For one, it's not an end-all framework. So there's a lot of hype that comes around Backbone. People seem to think that this is it, this is the thing, this is the new jQuery. And that's not necessarily true. It may not be the tool for your needs. After this talk, I hope you'll have a better idea of what it gives you, what it doesn't give you, and then you can make a decision on your own projects. But a lot of developers will use this as part of their grab bag. It's not jQuery. It's not something you just throw at a problem to solve it. This is going to fundamentally change how you architect your application. So it's not a light decision to make. It's not something you're going to switch out halfway through your application when you realize, oh, Angular would have been a better framework for our needs. Some good things about Backbone, though, are that it's very lightweight and flexible, so that it's very good for rapid prototyping and throwing together something. If you have a legacy system and you don't want a lot of overhead of another framework, it's nice to have this light single file that you can just throw into a page and then be able to take over a piece of markup. And one thing that's nice about Backbone that we'll see later on is that it's popularized a declarative style of basic class inheritance and event binding, which is really nice. So at a high level, it's a single JavaScript file that provides MVC-like functionality to the client side. It assists with the organization and structure of your code, not your file system. So it doesn't have any style guide on how you structure your file system, just the code that's within that. It relies on a functional utility belt. So what that means is something like map, reduce, each, extend. These things aren't inherently in all versions of JavaScript, and Backbone tries to support up to ES like 3.5, 4. It's like this in-between version that's IE 8, IE 7 around there. So it needs this utility belt to help with chaining and doing some more functional style coding. It also relies on a DOM library. There's some open issues right now to try and replace this and take out jQuery if you don't need it, because jQuery can be pretty heavy for some users. I don't really buy that. I think that it's lightweight enough and it provides enough functionality that it's a worthwhile complement to Backbone. And what it uses that for is querying the DOM. The DOM is kind of messy. It's non-standard, so jQuery normalizes all that. And it handles AJAX requests to be able to get data into your models, into your collections. So a little bit more information. Backbone's website is backbone.js.org. You can go there. It has all the documentation. It's really nice. It's one page. You can just find anything that you're looking for inside of that. And the source code is on GitHub. Now, a common mistake that a lot of new developers have are that they believe that master is stable. In the case of Backbone, active development happens in master, does not happen, there's no stable branch. So if you're looking for stable, look into the tags and then find the one that has the correct version that you're looking for. It's hosted on Jeremy Ashkenaz's profile now. It used to be a part of Document Cloud, which spun out of the New York Times. He's moved it back over to he's the primary author of it and pretty much the benevolent dictator of the project. So we're going to start getting into some parts of Backbone here, and I'm going to explain some of the positives and negatives of many of the features that it provides. So one of the most powerful features that Backbone has popularized is the use of events. And it's not just the fact that it gives you an events object that you can mix into other objects, it's the fact that it bakes them into its inherent constructs. So models will emit events when their state changes. Routers will emit event when their state changes. And what's nice about this is that it's very decoupled. You don't need to have any inherent knowledge about necessarily which object you're listening to. You can use like a facade pattern and kind of abstract away other parts of your code. That's a double-edged sword. That can get very confusing very quickly and hard to debug. But used positively, this can be very useful for listening to many state changes in different parts of the application. And like I mentioned, it gives you backbone.events, which is a mixinable object that gives you like on, off, trigger, listen once. There's a bunch of methods that you can look in the documentation and see. And the documentation also includes all the built-in events that you can listen to. Backbone has an inheritance method that works. I feel like it needs a little bit more, but it definitely works. Very few people complain about the inheritance because very few people expand outside of its built-in constructs. But this is how Backbone handles inheritance. So we see here, this is a model definition, and we'll get into models a little bit later, but since the constructs work the same across, well, the inheritance works the same across all the constructs, this is the pattern that you will use. So you start with a definition, and that's just extending one of the built-in constructs. Here, I'm making a model definition. We see that the first object that you pass in will accept a key value for properties that will be public, and that's available on all instances. The second object, very rarely used, sometimes it's used in like a more factory-like pattern, is where you put your class properties. And then we see below that you're creating a new instance, and then that will get the prototype that's off of that first object. So basically, in JavaScript, we don't have classical inheritance. We use something called the prototype, and then you set that once, then all instances from that inherit from the same prototype. So that can also be a double-edged sword. Any dynamic properties you put in there will be the exact same property for any instance. So for instance, if you put an array in there, you say my array, colon, and then you give it an array object, any items you push into that will be available on all the instances. And there's some ways around that we can talk about later. One other thing to mention is that there's a special method called initialize, and that's what gets triggered when you call new on an instance. Okay, so one of the issues that I have with the inheritance is what I just mentioned, is that creating a custom construct is kind of confusing. My issue with this is that it's not very Backbone-like. Everything in Backbone is this nice declarative way of setting up your code, yet if you want to create a custom construct, Backbone doesn't expose any of its inheritance methods. The only way it exposes it is tangentially through one of its constructs. So we see here that I've created a custom construct function. I'm extending the prototype. So this is what Backbone does under the hood. And then I give it some method and then a function. And now that's available on all instances when I create it. And then in order to actually extend this and be able to work with it further, you have to copy over Backbone's extend method into it. So this is how it works now. I think it will change in the future as more developers are creative and coming up with their own constructs that they would like to see put into their own Backbone-like framework. And that's effectively what you do when you get Backbone. It's so lightweight that you end up creating your own mini framework around it, and it's kind of nice that way. So routers I'm going to bring up very early on because they're fundamentally important to the way the web works. The web works by tracking state via the URL, and the client side has just as much access to that URL now as the server does. And it's very important to track this state. So if you hit refresh on your application, you don't want to send somebody to, what are they looking at now, back to the beginning of your application? If you're in the middle of a wizard, you don't want to send them back to step one. You want to keep them on whatever step they're on. The router is designed to take a key value of an identifier, which is a fragment that will be in the URL, and I'll show how that looks in the next slide, and a method name. So it's a declarative approach. You're not giving the instance of the method or a reference to it. You're just giving a name that will then get matched later on. So we see here that I have a comment that says route methods go here. We'll see later on how that actually looks, but think of it as a name identifier and then a function that gets called whenever that route gets hit. And you must initialize with at least one route, otherwise Backbone's not going to do anything. It's kind of a weird situation where you would ever create a router without any routes, but that is something to keep in mind if you're seeing some weird behavior, maybe because you misconfigured something. And what I'm doing here is I'm initializing the router. So this is something that happens when your application starts. And then I'm calling backbone.history.start. What that does is it starts tracking the URL. And let's say you're on a route that can be matched to the router. It'll actually call that immediately. So it's nice when you first bootstrap your application, this will kick it off. You can have multiple routers in your application, but just keep in mind, don't override routes because the last one that overrode is the only one that's going to trigger. It's not like you can create multiple routers and then have all these things trigger in different parts of your application. So by default, Backbone will use the location hash fragment. And the hash fragment allows you to track state without refreshing the page, which is fantastic. You don't have to refresh. You can just modify that all day, and there's events that the browser will emit that Backbone hooks into. And it also does not require a web server to be configured to use them. That's because, and this is now in the cons, the web server cannot read the hash fragment. And what's kind of bothersome about that is when it comes to SEO or refreshing the page, your web server can't make any intelligent decisions. It can only redirect you back to the index page and then let the client side handle the rest. This means it's unable to be parsed by search engines. Google proposed a while ago something called the hash bang, and the hash bang was a way to mark a fragment. Google would find that, then make another request to your web server where it would try and escape that fragment, and then your web server could send back the right content to be indexed. But this is just an abuse of technology. It's not a solution. It's not very intrinsically web either. What you should be doing, if that's something you're interested in, is using this new API called the HTML5 History Api, also known as push state. Now, push state can be trivially implemented within Backbone. It's a little more complicated with the server, but on the client side, it's very easy. It's just a Boolean that you set in the start method that I just showed. And then that turns your URLs into these great canonical, Tim Berners-Lee happy, friendly URLs that you can share with other developers and other people. And your client side will know how to read that. Now, the negative here is that your web server must be configured to handle this. In Nginx, it's usually try files. You try and make sure, like, hey, can we get this file? We can't get it. OK, go back to the index.html. That's really the easiest way to handle this. It's basically 404 redirection back to that file if the file doesn't exist. So that's one minor thing. And this also means that you must have a server in order to use push state effectively. You can use push state without a server, but when it comes to refreshing, you're going to get a 404 immediately if it's not configured. So now, views are very complex. I could spend the rest of the talk just talking about views. The plugin that I wrote, Backbone Layout Manager, was inspired because of how dead simple Backbone views are, that in many cases they're useless when it comes to building a large application. And I wouldn't say useless. I would say they make a great foundation. They're a prototype of how you should be structuring a view, but not without, it doesn't give you any of the code to do those things. So for instance, you would expect that a view in an MVC framework would know how to render. Well, it gives you a render method. It's just an empty function. So it's up to you to figure out how you actually want to inject contents into your view. The best way to think about views are that they encapsulate one piece of your application. And if we're thinking about it in terms of markup, it's one DOM element that gets associated with one view. So think of it that way. One element per view, you remove the view, that element gets removed. There's a lot of confusion with how this should actually function. Some users believe that it should just empty the contents of the view, but the element should remain in the DOM. That's not how it was designed. It's designed to really encapsulate and be tightly coupled to one element. So that's what we see with the first property. That element can be described such as a selector, and if you're familiar with CSS selectors, it's just basically you can give it a description of what you're looking for in the document, and it'll go out and fetch that element for you. It uses jQuery under the hood for this. You can also just pass it an object that's an element, and it will use that as well. And below that, we'll see later on how this works, but there's a declarative approach to adding events, which is truly unique within Backbone. Not many people were using this sort of implementation in the past. It was really sort of Backbone that pushed for the declarative approach, which is nice because it's a lot less code that you have to worry about, and it's much more succinct. And then I show how to initialize it here. So like I mentioned, there's no usable render method, and there's no data binding. A lot of the popular MVC frameworks now are popularizing two-way data binding between the document and your application. And in many cases, that's really useful. And just because Backbone doesn't come with it doesn't mean you can't augment it with it. There are plenty of libraries out there that provide two-way data binding that are drop-in compatible with Backbone. Okay, so models and collections. A model, basically models and collections encapsulate a ton of code in Backbone, and there's so much to talk about them because there's so many methods that get proxied onto it. But I'm going to boil it down to the simplest form that I can represent. A model can have a URL property, it can have attributes, it can have all these properties that get associated with it that you can see in the documentation. But really, URL is what I'm pointing out here because this is how you asynchronously fetch data to get it into your model. You will pass a URL that's REST compliant, and then it will fetch that data when you call fetch and put it into this model. And we'll see later on that there's some methods that you can hook into to parse that data and make sure that it's the right format for your model to be able to use. Below that, I have a collection now, and it's a collection of items. So we see that I've set the model type there. If you omit that, it'll just be a generic model, not too useful. You won't be able to have any methods or anything off of that unless you've augmented Backbone's model prototype. And then below that, I've initialized one item just to show one of the methods being called on it, and this is just setting data manually into it. You can also get data out of it, and we'll see that later on. Below, I talk about proxying functional methods. What this means is that when you have a collection, it proxies that functional library I talked about, underscore or Lodash, and it will take those methods, put them right onto the collection so you can instantly get access to map, reduce, each, and then run all of these things without Backbone having to re-implement all of them. It's really a clever approach of being able to augment a larger library within itself. And now I'm going to talk about a typical workflow within Backbone. So, and this is not just typical of Backbone. I've written Angular apps and I've worked on some Ember apps where they're very similar in this regard. So what you start with is creating your initial page markup, and this is just going to represent your initial application. This is what's going to be when you first load the app. And then you're going to define an application namespace. And I say here to attach constructs from, but really what you're going to want to attach to this are probably instances, like maybe a reference to your router so you can use it within your application. The app is just this global namespace that you use instead of dumping everything into the global scope. From that, you define all of your constructs. So when you extend your own routers, these are just the definitions. And we remember the definition between that and the initialization. You don't want to initialize right away. The reason for that is that if you separate your models, collections, and your views into separate files, you can now load them out of order, wait till your application starts, and then initialize everything. And we'll see later on how that's really beneficial with modules. So once all your code is loaded and all your constructs have been created, you kick off your router. And your router is, when you kick that off, that's really the application start. And the router is what creates all these instances. It creates your model instances, your view instances. I typically like a heavy router. I feel like that's a very good place to really see what happens at each state. Some developers like creating controllers and then working off of that. And you initialize your controller inside of the router and kind of abstract out that logic. And then from there, my views are created inside the router. Those hook into the DOM and then start rendering into the page. From there, you get models, and models are typically initialized around the same time as views. Those get the data, you pass the model into the view now has access to this model, and then it's able to use that and render internally. We'll see how that works with the template that's added in the application. And at the end, we have lots of glue to hold it all together. It's not enough to just define these constructs and link them together. There's other parts that you're going to need to put in. And we'll see what this kind of glue looks like. It definitely adds a little bit more to the page. But this is just what happens when you have a lightweight framework that doesn't take care of everything for you. So we're going to walk through a small application that basically tells you about the weather. And I've been having some spotty internet, so it's possible that the demo will not work 100%, but I have mocks here that show what the app looks like. So basically there's just a search, there's a navigate button that will, when you click that, it'll get the web browser's current latitude and longitude, and it'll fire that off to a API and get the weather back. So there's two states to it. There's technically 3 URLs just because you can enter in a given location, and that will be a separate URL from a latitude and longitude URL. And we'll see those 3 routes in a bit. So we're going to start with the initial page markup. In the initial page markup, in this case, I've dropped in everything that's non-dynamic immediately, so it's quickly rendered. There's no point in really making this a dynamic template because there's nothing changing in it. One thing to note is this div class weather. This is going to be an injection point. So I had talked before about how views will render into a given DOM node. That weather will be one of those DOM nodes. It'll be where a template gets constantly rendered into. And we also have to throw in our dependencies. So right now I'm taking the most basic approach possible, and I'm just using script tags, and I'm just throwing them right into the global scope. And I'm saying we need underscore, jQuery, and Backbone. We'll take a look at what the full index looks like in a little bit. I'm also using something called pure CSS. Pure CSS is an alternative to Bootstrap and Foundation. If you're working with rapid prototyping, this is a fantastic it's like one line that you throw in your page, and you can start immediately using the classes to style up your application. So it's very flexible. It's built by Yahoo, so I highly recommend at least looking into that. So that's what I've used for this application. I guess I don't have there it is. So here's the link to Pure right here. It's purecss.io, as I showed. Okay. So I talked before about the template. Now, since the basic implementation I'm doing here is as simple as possible, the simplest way to create a template for an HTML5 or modern web application is to use a script hack, which I just showed using script tags to load JavaScript. If you change the type to be something that's non-JavaScript, it actually doesn't get evaluated, so it actually maintains all the white space, and it's really kind of a nifty hack for embedding templates inside of your markup. We'll see later on how that's very inefficient when it comes to having many templates. But here I'm showing accessing a model. So I've passed in a view instance into the template. That gives me access to all the properties on that view. And since I passed a model to that view, that is now available. We'll see how all this passing works, but it's really quite elegant how you can pass things along and then use them at different stages. So in here, I'm simply grabbing the description off of the weather that's returned. So the API has this weird sort of array thing, and you have to grab the first one, and then you can grab the description. Okay, so before I get into that, I'm just going to switch over. Okay, so before I get into that, I'm just going to switch over real quickly into the markup for the basic implementation. And I'm not too sure how visible this is. It's a lot of markup here, but really the callouts are that there's style sheets up here, the pure CSS. I've added in just a theme. It's some basic CSS that gets hooked into on the markup. I've added all the vendor dependencies right here, and we'll see later on how these get. Right now they're out of order. I can just I can keep them out of order because the application start is really what kicks everything off. So that's kind of nice. But when it comes to actually building the application and optimizing, that may not be something that you can always rely on. So here's that template that I showed. It's actually quite large, so I didn't embed the whole thing. I'm doing some logic in here, and there are a lot of purists out there that do not believe that you should be putting much logic at all in your templates. You should keep them as logicless as possible. Since this is a small application, I wanted to illustrate using some of these functional methods. You can see here that I'm chaining the model. I'm getting this main property that comes back from the server. I'm picking out certain properties like the temperature, the pressure, and the humidity. And then I'm iterating over those, and then I'm embedding markup directly using this template engine. So it's quite simple. This template function comes with underscore, which is that functional library. So it's something you get for free. Also, my battery's running a little low here. Plug in. Plug in. OK. So now we're back here. So the application namespace. This is the simplest way to create a namespace. You just create an object, make it in the global scope, call it something like app or application. I specify a main element. This is a useful way of saying, where is my application in relation to this page? So if you can imagine you have a legacy application, maybe you have a CRM or something like that, and you want to make a new Backbone application in just one region of it, it's nice to say, here is my top-level element. I'm not saying it's the whole page. I'm saying it's just one region. And this is also a selector that's in here, and I'm using the body tag in this case. It could just as easily have been a div that's somewhere nested into an existing application. And it's nice because it doesn't collide with other parts of your code. I also like to store constants on my app object so I can use them in other parts of the app. So here I'm storing where the API is located. Okay, so starting the application, I've talked a lot about this. It's really simple. You basically just have one method called start, and that's what you call when you're ready to actually kick off the application. And that creates your new router, assigns it to the app so you can use it in other places, and then calls that Backbone history.start that I talked about. And what that looks like, in practice is this right here. So it's simply just app.js, and in fact, I might be able to increase my font size here. I can never. Do I have? Yeah, it's 5s. Get over there. 5s, 20. Okay, so that might be a little more readable now. So this is where I'm kicking off the app start, and we'll see that actually being triggered. Oops, well, I guess when I do that, unable to see the rest of it. Let's get back in here. We'll see down here where it says app.start to start the application. And that's after all the scripts have actually been loaded off the app. Pretty simple. OK, so the router. This is where the meat is. And on this slide, there's just no way I could put all the code that's involved with here. But we'll dive into that and just see what this kind of looks like. The router for me is just the central point where I like to put all my truth, my constants that are in the application. So constants like the DOM. What elements are not going to change that I'm going to want to reuse over and over again? Are there any templates that I'm going to want to reuse over and over again? Maybe I should put those as well into the router. Anyway, this is where your state is controlled. And I had talked before that there's 3 different routes. And we see here how you actually define a route now in the router. The top one, that empty string, means this is the root. You don't put a /, you just put an empty string, and that indicates this is the root of my application. And when I'm on the root, I want to go home, and then that will trigger the home function. Any parameters that you give, they're used the syntax where it's pretty common now to use a colon to indicate a parameter and a asterisk to indicate a splat. The difference really between that is that a parameter exists between slashes and a splat can contain slashes. So you would use a splat if you were looking for like a file name or something, or a file path. So here I have the 3 routes, and the first one just goes home. The second one will take a city parameter, and we see that when we call show weather, city is now going to be passed in as whatever that value is that you've passed. And then you can use it within that function. And the same goes with the lat and long. Okay, let me take a look at that function as well, or that file. So the router is a beast. It's pretty big. There's 21 lines just in the initialize. And here I've assigned those DOM constants. So there's the background, which I animate at some point, and the weather element, which I use to actually inject in that template. I create my weather view inside of here. I create my weather model, and we'll get into that in a little bit. But basically, I create my models, my views at the exact same time in the initialize. So that's as soon as this router gets kicked off in the app start, these things are created and available. And I use this dot in all of this so that it's available between all of the methods that are inside the router. From here, I create a new form view, and this is where I pass in that model. So I talked about passing in a model. As soon as you pass in a model like that, it is now available as a dot property inside of that view throughout the entire view. It can be inside the template or inside of any of the methods. And then here's some of the glue that I was talking about. So in this case, it's a little funky when you use CSS transitions because when you reload the page the first time, all the elements get rendered and they get animated. So what I like to do is disable animation. So I just set a class that's called, basically if the class animate does not exist, none of the CSS transitions. This is just some of the glue that has to get added in. So the weather model that I just talked about takes a URL as a function instead of a string. And the reason for that is if you have any dynamic properties that you want to associate to that URL, so maybe it's a query parameter or something that needs to go in, you can't do that with a string because the string is evaluated immediately, but a function is deferred until you actually call fetch. So the function here is actually very useful. And another useful function is parse. And parse is what is triggered immediately after content is fetched. So we'll see how I utilize that and is fetched. So we'll see how I utilize that to kind of cheat a little and do some pre-formatting. So the URL function looks like this. So if we have created the weather model, and if we have something that's latitude and longitude, or do not have latitude and longitude, it's just going to append that city name that we've searched for. But if it does have latitude and longitude, it's going to grab those out, and we see here in the model, those will be actual attributes that you can call get on, and get those out, and then apply them into the URL. This is fairly typical, especially with some non-standard APIs, to be able to get access to things. Like if you had a search model, you're going to need a query parameter in there. Backbone's not going to know how to set that up for you. Okay. We also have a parse method that I talked about. That gets a response object. That response object is literally the data that came back from your server. So here I am just doing some modifications, converting Kelvin to Fahrenheit to make it a little bit more usable. I don't really know Kelvin all that well. And this has humidity, pressure. I'm just basically doing some normalization. Why you would not want to do this is if you're ever persisting back to the server. So if you're persisting back to the server and you've now modified the data in your local model just for your own convenience, you're now going to modify the original data that's going to be on the server when it comes to save. So oftentimes parse is really just used if your web server returns data maybe underneath a data namespace. Sometimes web servers will do that, and then they'll have like a paginator option as well. But you only want the data inside your model, you'll just grab that. And then going back out, there's a method called toJSON. So if you were to save, the counter, like the opposite, would be toJSON, and that's when it goes back out. And that allows you to reconfigure the object to head back to your server. All of this is in the Backbone documentation. It's to go through the entire method API. Okay, and lastly, we have the two views that are going to be created. The first one is the weather view, and this is the one that has a template that I showed, that script tag. And then we have the form view, and that's the one that has more events and rich functionality with grabbing the right value from the search and then actually calling that weather view to re-render. And we'll see how that works. Okay, so we'll start with the weather. Okay, so we'll start with the weather view first, because this one's really kind of lightweight. What I start with is grabbing that script tag. So I put an ID on that script tag, and now I can grab the contents immediately out of it, and now I have a string of the template. And then I use underscore here to actually templateify it, make it a template function that can be called repeatedly. Inside my render method, I simply call that template and I pass in the view. That's how that view gets used within the template. So I simply just pass that in. The template function expects an object. So since the view is an object, I can just pass it right in. Now I can access any of its properties. And we see this.$EL. This is a very good feature of Backbone that it automatically assigns. So when you create the weather view and you pass it the element that you want it to be in, this is now available to you as a jQuery object. And it's really nice because it's encapsulated. You only really modify everything inside of that view. And that's a good way to write these things. Always write, if you're going to modify the DOM, modify it within itself. It's scoped in that way. And then we have a render failure. This one's just called if there's any kind of error, like let's say the server failed and it couldn't actually hit the API and get any data. It simply just gets called here, and it just injects some HTML. Okay, so the form view is a little bit more complex. This is where it has that events declarative binding that I was talking about. So here, whenever there's a click on the input, we're going to want to change the weather. Whenever you submit, hit enter inside of the form, we're going to want to show the weather. And then whenever you click that detect, which is a little icon that shows up, let me see if I can get that app. So this little icon right here, whenever you click this, it's going to try and get the location, but since I don't have any network connectivity right now, I can't figure out where I am. But you could also type in, and then it will try and get the weather for what you need. Okay, so to change the weather, simply all this does, so when you click into the input, so let's say I'm back in here, and we're in a separate state right now. I wish I could show the URL. Right now, we're actually at /Boston. When you click in here, we want to go back to the beginning, and that's what this change weather method does. So when you click, it will go app.router, and that's why I put the router on the app object. Now I can use it wherever. And now I'm going to call navigate. I'm going to give it that empty string to go back home. And that comma true. Comma true is important because without that, it will not trigger the function in the router. It's kind of a weird design decision, but there are many people who design applications where they do all the modification and then they call navigate just to update the URL. They don't actually want to call that function again. It's not how I've developed, but I've seen some applications done that way. And then I reset the input value. So just some of the glue that has to happen in here because we don't have data binding. Show weather is what happens when you click submit. I blur the input. That's just some glue that has to happen and makes the transition a little bit smoother. And then I call navigate, and I pass it in whatever the input value was. And this is how we get that city value inside of our router. And the return false here, this is actually a jQuery thing. It's kind of interesting that these functions that you're defining are not really Backbone view functions. They get proxied into jQuery. And jQuery has this way to stop events from bubbling up and getting out of control by hitting return false. So basically, if I didn't have return false here and you click submit, it would actually try and post to itself. So we just want to kill that off because the client side is handling it. Okay. The auto detect function is a little bit meatier. This is where I actually get into one of the new web APIs, which is being able to get your current location. I'm not going to go into this in heavy detail. You can look at documentation online on how this stuff works. But what's important is to note that there is a timeout here. And when it errors, I just specify inside the input, hey, we can't get your location right now. Okay. So yeah, there's a lot of code in here. What else do I have? Oh, and the way that I got this .input is I just cache. So typically in Initialize, I cache all the things that I'm going to use within the rest of the application, so I'm not constantly re-querying the DOM. Every time you query the DOM, you take somewhat of a penalty, and it's just better practice, I think, to not repeat yourself. Okay, into the slides. Okay, so we now have a fully functional web application. It's actually not that much code when you think about it. We went through, I believe, all the files in here. And if we run an HTTP server, so that's on 8081, and let's see if I can, actually get that open. So that's localhost 8081. And that's it running right now on just a vanilla HTTP server. There's nothing special involved with here in order to get this running. So like what's left? I mean, we just built the application. If you're at a company, everyone's so excited because everything's done. But how can we improve this? What happens when somebody else comes into this application? They're trying to figure out how everything works. One of my biggest frustrations as a contractor, and I do some contracting work, is when I get into a project that's custom written, where everything's not invented here, and the developer has to create everything their own way, either because of lack of knowledge or just like an ego. What it really needs to come down to are leveraging the best tools for the job and being able to onboard new developers very quickly. For me, the biggest waste of time is looking at a project that I can't understand and that I'm spending so much time just trying to figure out why did someone do it this way. There are better ways of doing it. So really the biggest thing for me is be consistent, use a consistent workflow, and then you're going to have an easy time onboarding new developers. You're going to have an easier time getting back into the code later on. All right, so now we're going to get into tools. The biggest, the most prolific tool you're going to need as a client-side web developer is Node.js. You can't get around it. Every tool that I'm about to talk about uses Node.js. It's definitely the client-side developer's choice for developing tools just because it's JavaScript itself. It uses Chrome's V8 runtime on the server, and it has a very simple installation. It works on all the major platforms. Microsoft is a major contributor into this, just to make sure that it works on the Windows platform. And it bundles NPM with it, which is a nice package manager. That's not what it stands for, but it is a nice one that we're going to use throughout this. So one of the biggest things that we need to do here is manage our vendor dependencies. I just threw Backbone underscore and jQuery in there, and I was like, oh, man, I hope this works. I don't even really remember what versions they are in there. How do I know that they're actually going to work together? Developers have had this problem since the beginning of client-side development and probably since the beginning of development period. We need a package manager to help us manage our dependencies and make sure that all developers know what's going on. Because when you have a new developer come in and you're like, oh, hey, I'm going to go grab this JQ grid plugin, I'm going to throw it in the page, how do they know that it's even compatible? Where did they get that from? They just Google it and found it on GeoCities? You want to make sure you're getting the official source for any script that you're going to want to use in your page. And that's where Bower comes in. For the first time, we actually have a package manager and that is useful. There's been many attempts in the past, but they never gained traction. Bower gained traction because it's backed by Twitter and Google and most of the community. So this is a very useful one because it pulls directly from repositories. And what's nice about that is if somebody hasn't registered their package with Bower, you can just point to a Git URL and grab the entire source and pull it down, which is fantastic. It handles your versioning and resolution, so any of these official packages that have metadata associated with them, and I'll show how to configure that in the next slide, but it will handle the versioning and resolution for you. And the best part about it is it has the libraries you want to use. It has all of them. I have yet to come across a library that I absolutely must have in my application that isn't in Bower or isn't trivial to add into Bower. So to configure it, this is at a very high level. This is the bower.json file. This is a manifest file that goes in your application. And this is also the same format you would use to publish your own library to Bower. You just specify the packages and versions that are in your dependencies. And it follows Semver, so you can just follow that, and this will upgrade at the patch releases. And then once it's configured, you can just run Bower install to install. The one thing that you need to do here is the npm install, and this is a global flag, and that just means that it will go into your system-wide preferences so you can access it from anywhere. Depending on how you configured, you may need to have elevated privileges to install that. Another big issue is the fact of modules. So I talked about these independent script files, and what's frustrating with them is that they have no notion of what they need in order to run. The scripts are now trusting you as the developer to organize everything correctly, and that's cognitive overhead that you shouldn't have to worry about. JavaScript does not have modules, as I mentioned before, and unfortunately there's a lot of competition and competitive philosophies on how you should structure your modules. Where I'm going to go with this now is talking about the competing formats. AMD is an asynchronous way of fetching modules, and there's Common.js, which is the competing format, which is a synchronous way of fetching modules. AMD is more geared and suited towards client-side web applications, while Common.js is more suited to Node.js development. What Node.js will do is every time you call a require to get a module, it will synchronously block and load that file. So typically when you run your Node files on the server, you put all those at the top, get them out of the way, and now your server's running just fine for the rest and it doesn't block. You don't do that on the client side. Blocking is a janky experience and often can crash a browser if it's something that's long running. Another thing that's interesting about module loading is the fact of resource loading. So we had put our template in line in the markup, and that's not a very efficient way of loading in the template. It's not a very smart way of organizing it either, especially as your application grows. It's not uncommon to see 20, 30 templates in a medium-sized Backbone application. Backbone really encourages having small templates that are refreshed and re-rendered often. And it's a maintenance nightmare to have those all embedded in your markup with broken syntax highlighting and being unable to find the correct template that you want and having these weird identifiers to be able to uniquely find each one. Just use the file system. That's unique enough. And how can we intelligently load these? Require.js is by far the most flexible module and resource loader that you can find on the client side right now. It's also one of the most popular and well supported. So if you're looking into architecting a very large application with hundreds of dependencies and being able to load dynamic resources and kind of convert those and make them work, such as like a template, this is a way to go. It uses the AMD module format, which is the asynchronous module definition that I talked about. It works with or without a server, and it has plugin support for loading templates. You may have to use a plugin for that or the included text plugin. It manages the dependency graph of your modules, and it handles the optimization of concatenating, minifying, and generating source maps. This is fantastic. This basically means you don't have to think about it anymore. As long as you configured everything correctly, whenever you run your optimization process, you're going to have one of the most optimized builds and flexible for debugging in production. The source maps allow you to take that concatenated file that's minified, one line of probably 1 million columns, and bring it back to what it originally was on the file system. And that's just by this one giant map file that it generates that's only fetched when you have your developer tools open. It's really, really handy. The cons of Require.js are that it's complicated to debug and it's nearly impossible to configure if you've never used it before. So why are we using it? I talked about using easy stuff. Well, it's really easy to get this thing configured by using a boilerplate and then just moving forward from that. I would not recommend just jumping heads in to Require unless you're doing a very simple example. Do not just think you can architect your entire application without ever using Require.js before. It does not work that way. So to configure it, here's a very basic config runtime that you can use. And you have to map your identifiers to paths so that you can easily do like require Lodash or require underscore or anything like that. And if you use a library that's not AMD compatible, you have to do something called shimming. This is something I introduced in a plugin a few years ago that recently got rolled into Require. And it's handy when a script does not know about its dependencies or what it exports because it's just JavaScript. So here we just provide that metadata for it. And what's nice about AMD is that it's gaining even more traction now. Backbone just landed AMD support, so the next version of it, you can actually eliminate that shim object and just point to the mapping of it. So testing. Do we even know how to test what we just wrote? Like, what's our strategy here? How are we going to do this? Is the testing strategy we come up with going to have continuous integration? Is it going to have code coverage? Are we going to be able to get intrinsic value out of what we're testing? I would recommend looking into Karma. Karma is something that I've been spending a lot of time with recently, and if anyone went to any of the Angular talks here, I'm sure you've heard of it. It's built by the Google Angular team. In my opinion, it is the single best strategy for client-side testing. It's still a little buggy, it's getting some of its rough edges fixed out, but it's very plug-inable, and it has great code coverage, hitting Sauce Labs, browser testing, and continuous integration. So managing your project, and I'm going to have to rush a little bit here, I have 9 minutes left. There are real problems that developers face when it comes to organizing and structuring your code. What if we had a make that had plugins that you could just grab that just did things that we needed to do in our project? This is effectively what Grunt is. So if you go to the Grunt website, which is gruntjs.com, you'll see that it has a list of plugins. Internet's not on. But if you go there, it has a list of plugins. You can search through all of them. And what it's nice about it is that it contains plugins for stuff like Require.js that I was just talking about. And then you can just use the configuration examples in there to get going with your own project. Configuring it's very easy. You just use a Grunt file in your root. You can take a look at the code that I'm going to share at the very end of this talk, and this will have the whole thing filled out, and you can see how those things are actually configured. But it's a pretty typical process. You configure, you load the tasks that you need for the plugins, you register those tasks, and then you can run them. Installing is a little bit different. You have to install a Grunt CLI globally. What this is just the command line interface, and then it loads a Grunt that's installed locally. This allows you to have multiple different versions of Grunt, versus Bower, where you only get one version of Bower. You can have multiple different versions of Grunt in different projects, and the CLI will just load that one in. It's a very smart way of developing this. Okay, so we did all this work, and we're talking about configuration and all this complicated stuff with projects, and it's prone to failure if you've never done this stuff before. This is why I built Backbone Boilerplate. So Backbone Boilerplate is available on github.com/backbone-boilerplate, and then there's a list of all the repositories in there. The wiki is available here. This has getting started guides. This is giving you a foundation for creating a brand new application. It has a scaffolding tool that you can use if you wish, like to generate out models or what have you. But really what's nice about Backbone Boilerplate isn't that I've created this custom framework to help you build an application. I've just assembled all the hard pieces together. I've taken all these popular projects, Bower, coveralls will report your code coverage, Karma to do your testing, Backbone's included in here, Grunt is completely configured. It's ready to go out of the box, and I'm constantly improving it. It's been developed over the past 2 years. There's been tons of developers that have put a lot of time into this. And some of the cool things about it are that after you've downloaded and installed this thing, you can just run your tests whenever you need to on the command line. And while you're developing, you can actually keep a daemon running, and it will automatically find any files named something.spec.js. So it's very easy to add new tests. I find one of the biggest problems and challenges with writing tests are having the overhead of, oh God, I have to now add this into this file array somewhere else that's deep in this code file. And this is how I was doing it for a long time. Karma allows us to dynamically load test files very, very easily. And since we have Bower in here, I've been able to add in some other testing libraries that make it a lot easier. So you can use, I believe we support Jasmine, Mocha, and QUnit out of the box. It's very trivial to switch between them. It's just changing one line in the Grunt file. And it just automatically loads them. So if we look at some of these spec tests in here, so this will load in Backbone. It'll load in your router. And this is using that AMD that I was talking about. So this is requiring those modules. We just described that we have an application router. It exists. We just expect it to be truthy. And is a Backbone router. So this is very, very simple. The tests run just fine. You can put this out on Travis CI and do your continuous integration that way. Submit results to coveralls, and now you have a nice way of seeing all your test results. Now, what's really interesting about this is the code coverage. So the code coverage with AMD, and you only really get this with AMD, is individual per file code coverage. You don't get this with CommonJS because that has to build everything into one bundle. So you get code coverage over one giant file. The nice thing about this is when you go through it, you can immediately see what your tests are actually hitting and how well you're doing. So I have 5 minutes left. I'm sorry of this and that we weren't able to fully appreciate the joy of writing a Backbone app together. But if you have any questions, please feel free to ask. So thank you. Also, I'll be around afterwards. I got stickers if anybody wants some Bocoup stickers or business cards or what have you. So, yeah, in fact, it might just be easier if you just come down and ask me yourself if you have any questions.